Lava. I know the talk in the other room is very interesting. I don't blame other people because I would have gone there if I'm not doing the talk here. Because we have a very small crowd, I would like to make it a conversation, but I'm just conscious that this talk is also on stream. So if the audience starts to talk, you guys start to talk, people may not hear you on stream. So, but if you do have questions while I present, feel free to stop me anywhere. I'm very much, you actually make my life easier by making this a conversation, because it's really, really challenging to do a 45 minutes technical talk without putting people to sleep. So we are going to talk about cloud native development for small teams. So I run a independent game studio, a very small team in London. I just actually released the Whispers in the West at end of the July this year. So currently I'm not doing much, that's why I can travel. I started my career as a board game publisher. And about a few years ago, time passes so fast, I think. About 10 years ago, I made a big career transition to go work in tech. That's where I learned a lot about cloud technology. But I missed being in the creative sector so much. So in 2020, I decided to make a comeback to the games industry. The first game I did was Rings 3 Kingdoms. Some of you may have heard of the Rings mobile game series. So it was a great opportunity. I was a contractor on this project. If you have a Netflix subscription, you actually can get access to this game for free. And as I mentioned, this year in the summer, I released another game, Whispers in the West. I'm not used to this. So before we start, maybe just a few very short words about cloud native. How I define cloud native is it's basically a transition from servers to services. I think most of the audience here probably still remember the days that you need to send a file to your friends, and then you upload the file to an FTP server, and then your friends download it. But obviously nowadays no one does that anymore, because we all know like things like Dropbox or Google Drive is much easier for this purpose. So this is an example of how we transitioned from using servers to services, a very simple example. So in this talk, I will touch upon a bunch of different services. And don't worry if you are not going out of the room and deciding, okay, I'm going to use all the services, because there's no expectation you should use all of them. And you may have used some of them as well. And this is by no means expert level of explanation of all the services. I think the idea of this talk is just give you some, maybe some inspiration. Okay, those are the things that may make your development life more productive. So what are the benefits of using cloud native services? I summarized as three, in very simple words. First, services are usually more reliable than servers. So you go on a beach holiday and you come back, you should expect services are running as it should be. And also it supports a higher degree of automation, because being cloud native means the services are hosted in the cloud. And it means when you need those services to work together, to talk to each other, they will. So it's cloud native is very closely related to automation. And third, it doesn't cost a lot for small projects, small teams to make use of these services, because most of the services, they are charged by usage, means the less you use, the little you pay. And as we are small teams, the chances it doesn't cost us much to use those services. This talk is not about my game, but I think it's probably better if I give you a little bit of context what this game is about, what the challenges were, and so you can understand why we were doing what we were doing. So Whispers in the West is an online co-op murder mystery game. The first thing you need to know is it's episodic. So each murder case is about an hour long, and the players they are relatively independent with each other. So players can play one of those cases, choose one of those cases to start with. And each episode is offered as a DLC. And a little bit twist to traditional co-op gameplay is in our game, we said to players, only the hosts need to buy the DLC. Other players, they can just join the game for free as long as the host owns the DLC. This message is very much appreciated by players. I really truly hope like more co-op games can work like this, because sometimes I play a lot of co-op games myself, but it's always embarrassing to invite my friends to join a game and tell them, you need to spend £10 to buy the game. Let's get started in our main topic, cloud native development. So because it's the technical talk and it's often quite dry, so I arrange it in like a level up format. We'll start from level 1, level 2, and we progress to level 4. In level 1, you probably will find a lot of services familiar, or you may be already using. Actually, before I start, since we have a very small room, can I have a show of hands, like how many of you are developers or self-recognized as developers? That's very cool. Okay, you don't need to be embarrassed to self-recognize yourself as developers. Your secret is safe here. So the first recipe I want to introduce is related to Unity. I know we developers have a love and hate relationship with Unity, but we probably haven't switched to other game engines just as we speak. So if you come from a world of Unity, you probably know Plastic is kind of a first-class version control tool Unity now works with. It's a replacement to Unity Colab. Plastic is unlike Unity Colab. Plastic is a fully fledged version control tool. The most significant benefit you get from Plastic as a version control tool is you can now do branching. And version control is something I always say to a lot of solo devs. Like even if you're a solo dev, I think a lot of solo devs, they kind of resistant to version control. I'm just working myself. Why should I use version control? But as people who use the version control can tell you, like even you are solo dev, you probably can still benefit from version controls, because what if you want to experiment something that you're not sure about? So here is like branching is something will come in handy. Like for example, you can have a development branch and then you have a release branch. You can build your game always from the release branch, whereas you can do some experimental work on your development branch. So this is like the best benefit from version control offers. And with version control, you can plug Plastic with Unity Cloud Build as well. So Unity Cloud Build is a build automation service that Unity offers. It's a very basic service, but it does its job. So what it means is you can run a cloud build to build multiple versions of your game at the same time. For example, you may build a Mac version, a PC version, a mobile version, all at the same time that you don't have to build from your own computer. So this is especially valuable if you are a PC developer and you want to build something like, for example, for Mac, for iOS. Another basic recipe in level 1, I believe a lot of game devs are already using. So you can have your game design specification in Google Sheets. An example is actually Rings. So Rings is a mobile game narrative mobile game, and all the data that Rings used are defined in a huge spreadsheet. I'm not going to go very much in depth of what is inside the spreadsheet, but if you are interested, you can check out Francois, the designer of Rings, his talk at GDC 2017, some years ago. So with Google Sheets, you can use Google Sheets .NET SDK with Unity, so you can load the data from Google Sheets directly into Unity. And this potentially can save you tons of time. And if we want to go a little bit further, the most challenging part of using any API is probably doing the authentication and doing the authentication right. My recommended way of doing authentication is to authenticate as a service account. The service account is basically a non-user account, so you are not yourself. The benefit of not being yourself is if you authenticate as yourself, you basically authorize more likely than not, you authorize the Google Drive to access all your data in your personal Google Drive. Whereas if you use a service account, you can actually have this additional layer of separation. So you can define a service account that only have access to this particular spreadsheet. And in Unity, it actually doesn't take a lot of lines of code, and you see the code here, most of them are actually just comments, and really just a few lines of code that you can integrate Google Sheets with Unity. And this slide is actually not the main point of this talk, but I just really want to introduce it because I find a lot of people who use the Google Sheets for years still didn't know this feature actually exists. Did you know that you can use the Google Translate formula in spreadsheet and translate something really quickly and conveniently? Maybe this way of translation is not suitable for your final game, but as like a placeholder, I think it works really well. So that is level 1. So how many people you are already at level 1? I'm sure quite a few you do. So we are moving to level 2. Level 2, I'm going to talk about cloud-based task runners. So task runners are for automation, as we already introduced before. Automation is so essential, like in cloud-native development or any modern development. Why is this? Well, we can talk about maybe for hours about why automation is important and how it can help you. I think the most important reason is it saves you time and reduce the chances of mistake. And as a cloud-native development methodology in automation, the additional benefit you get from cloud-native development is that you can integrate different services together to make your automation more convenient to users. For example, I'm sure a lot of you already integrated some of your tasks with like Slack or Discord. Just say, for example, if an automated job is completed, notify my developers on a Slack or Discord channel. A lot of people are using this. This is a simple example of how an integrated task can help you, like in real life. There are many cloud-based task runners. Under the hood, they all use similar technology called Docker. But as game dev, we don't really need to be an expert of Docker. We just need to consume those services. And there are a bunch we can choose from, like GitHub Actions, Circle CI, and Game CI. I personally haven't used, but I heard good things about it. And Game CI is also a service that can replace Unity Cloud Build we mentioned in level 1. So in this level, the recipe I want to introduce is using GitHub Actions. With places in the West, the project I just worked on, we used a lot GitHub Actions. For example, here, this is an example of how we use this GitHub Action task runner to automate the conversion of our game scripts into process data. So as we introduced before, in our game, we have a lot of data like games design specifications defined in Google Sheet. Some of them, they are written in plain text, in a plain text format. So we have those GitHub Actions to convert those data and maybe combine those data together and generate process data either in JSON or CSV format that can be directly consumed by Unity. Here are also a couple of other examples. So on the left-hand side is simply just a format checker. So I just mentioned like we have these game scripts defined in plain text, but following a certain convention. So as you can see, like we all humans, the writers are humans, and the writers make mistakes. So we have this micro task to basically find out what might have gone wrong, and so writers can check themselves without, so basically tell the writer, okay, this format is not right. And on the right-hand side, I'm sure if you worked on localization, you can sympathize with this. After a game is localized, you have so many, just hundreds of text assets. And sometimes you definitely, after the first pass, you definitely have missing translations. So we build this automation to actually check what files are missing for each language. And in our for our game development, we also have different environments: dev environment, staging environments, live environment. So we really end up with hundreds of files. And even after this automation, even this automation task takes about 3 minutes to run. So you can imagine if we were to check it manually, how long it would take us to check it. And this kind of automation, we can really schedule it or let it triggered automatically if a change happens. So it's really handy for us. And this is a workflow definition file. So if you have never worked with task runners like this, you probably think this is like aliens language. But if you have worked with, if you just spend maybe half an hour looking at the reference, it's actually quite self-explanatory. So basically it runs on a Ubuntu Linux machine, and you give it a name, and it's updating shared data, and then the following are the different steps that this automation performs. It's actually not that daunting and as it looks like. So this is level 2. We talk about cloud task runners, and we use the GitHub Action as an example. So let's move on to level 3. Level 3 is about object storage. Don't be fooled by this name, object storage. So in level 3, we are moving on to the, let's say, the public cloud sphere. Like so far, we have been consuming cloud-based services. So if you want to use something like more advanced, you probably will have to start using public cloud. I believe some of you may have heard of Amazon Web Services, AWS, or Google Cloud, or other cloud services. I think the reason I put object storage as a separate level is it's really so useful, and it's probably the easiest place to get started if you were to get started on a public cloud. You can imagine those object storage is just a advanced Dropbox or Google Drive. It allows you to store things in the storage buckets, and then you have a more relatively more advanced API allows you to access those objects. So before, actually, I forgot to mention, like, you remember that we said you can actually load the data from spreadsheets to Unity dynamically. But this method is actually, you can only use it in development. You cannot use in a production game, in a released game. You cannot expect to get data from Google spreadsheets dynamically. Why? Because there is actually very low API limit, because this getting data from spreadsheets is not supposed to be used at larger scale. So if you want to host dynamic game content at larger scale, you can use like cloud storage. It doesn't have to be Google Cloud Storage, any cloud storage. They all work in a similar way. And similar to accessing data from spreadsheets, almost exactly the same way, you can integrate Unity cloud storage SDK and access data dynamically from cloud storage. For example, if you have a game that is already published, you don't want to force the players to update the game every day, but you do want to offer dynamic game content. You can use it this way. So you upload the game assets into cloud storage, and whenever the player launches the game, the game calls the API and gets the most up-to-date content. So this is the idea of the dynamic game content recipe. In our game, we went a step further, because you remember we said we want to offer the game story, the cases as DLCs, and the players can share the DLC with their friends. So essentially, we want to have DLCs, but we also want the DLC to be dynamic content. So how we solve this is actually quite simple. We store the game assets as encrypted content, and we can always update the content in cloud storage. But in the DLC, it's just a decryption key that allows the players to decrypt those content. So this is a quite simple solution to solve a problem like this. So in level 3, we talk about cloud storage. Does anyone have any questions so far? I'm just going quite fast because there's a timer constantly reminds me. Yeah. That's a very good question, I think. So in our case, we dealt the versioning. Actually, we always have a intermediary step that is converting the data in Google Sheets into whatever format the game requires, and store those converted objects in cloud storage. This is how we did it. We basically just treat sheet data the same way as other data. But I guess you could have a name convention, just have different sheets. Yeah. I'm not exactly sure that the API allows you to access different, because Google Sheets does have versioning. I'm just not sure off the top of the head that whether the API allows you to access specific versions or not. Cool. So we move on to level 4. So level 4, I will introduce more cloud services. So first, and the most obvious one is, databases. And there are so many cloud native databases. And they really, really work almost exactly the same way as no matter Google spreadsheets or object storage, as long as development is concerned, because gone are the days that you need to spend half a day to set up a database. Nowadays, like most cloud native, like newer databases, you can just pick up and run really, start working really fast. You only need to care about what you need to develop without the need to worry about how the database is set up. And the database, again, is a very huge topic. Amazon DynamoDB, so DynamoDB is a service on AWS. It's probably one of the most popular cloud-native databases. It's really easy to get started, and Amazon has written some really excellent articles, white paper articles about the use cases and design patterns. So if you have a need for cloud-native databases, I highly recommend to check out those articles. And I will talk about a little bit fun use cases. For example, in our project, we use the Firebase for Twitch extension. And we have a specific, well, this is our proof of concept. We have a very specific fun proof of concept. I don't know, like here, like, do people know, like, does everyone know what this is? It's a Christmas cracker. It's a Christmas cracker in the UK. People usually do this at the dinner table. So the idea is everyone is given like a Christmas cracker, but you have to open it with another person. And inside this cylinder, there's usually like a little gift or just a word of blessing. It's a very fun activity like people do at Christmas dinner table. So we wanted to develop a Twitch integration that allows two-way communication between the streamer and the audience. So most of the Twitch integration, as you probably know, are one way. So the audience send a command and then something reacts in the game. But we want the streamers and the audience collaborate. They have to pull the Christmas cracker together to get it open. So we use the Firebase for this. So what happens is like the Twitch we have a Firebase, we have a bunch of Firebase cloud functions. Those are functions basically is a simple task that you can define the logic yourself, okay, do something, and you can interact with the database. In this case, Firebase real-time database. And we essentially we have two clients that uses these cloud functions. One is in Unity. We use Unity web request to trigger the cloud functions hosted on Firebase. And then on the Twitch extension side, it's a lot easier because Twitch extension is basically a web application. So we also call the Firebase cloud functions from the Twitch extension website. So whenever the streamer or the audience calls the cloud function, it updates the state of the Christmas cracker in Firebase real-time database. And the Firebase real-time database is also capable of notify the client if a change of the state happens. So this way we managed to actually develop this proof of concept for Twitch extension. I should mention that I actually didn't personally develop this Twitch extension myself. A developer from my team did it like in a few days' time, and previously he had almost no previous knowledge of how Firebase works. So it's just an example to show that cloud-native services like this, they are actually probably much easier to get started with than some of you might expect. And with the experience we had with this proof of concept, we also used the Twitch integration in our own game. So That's level 4, and I have maybe about 10 minutes. So I'm going to, so we're going to have some fun because we're going to talk about some services on the horizon. This may be a quite controversial topic, and because we have a relatively small audience, if you have an opinion, you can just put your hands up. We can discuss about it. And this is something we actually discussed yesterday at dinner. So obviously there are a lot of AI services that there's a lot of buzz around AI nowadays. And this is the third time I do this presentation. The first time was in March this year. And I think in March, like Maker Suite, this thing didn't exist. It just shows how fast things are changing, things are moving forward. I think AI, obviously, there's a lot of, especially AI-aided game development, there's a lot of controversy and debates, discussion around it. I personally think is like any new things, there are always going to be debates, discussions, and on the way, we probably will make mistakes, but because I'm positive about humanity, I'm confident that we can find a way to actually solve those problems. But yeah, I think the technology is already there. It's very difficult to turn the clock back to say, okay, just pretend those services don't exist. Interestingly, like, especially I think among dev circle, I think the general sentiment is, oh, AI is really poses a lot of challenges. But at the same time, I think a lot of people I spoke to privately, they mentioned that actually they already started using AI on daily basis for some very specific tasks. I think those tasks, some of these use cases are probably less controversial than others as well. For example, for myself, I frequently use ChatGPT or similar services for brainstorming because it's a really good idea. For example, when I write some stories in Whispers in the West, it's a game set in the Old West. So I asked the ChatGPT, okay, what are some of the professions people do in the Old West? And then the machine gives me some answers and some ideas. But it doesn't necessarily mean I have to take those ideas. It's the same as if I do a Google search. It's just a different way of doing things. I suspect that actually many people here are doing brainstorming with AI already as well. And another use case is text flavors. Text flavors. Yeah, it's a misspelling here. What do I mean by text, the flavor of the text? So, for example, again, use the example of writing a Western game. And as I'm not a cowboy, as you can see, I don't necessarily know how a cowboy would express a specific sentence. So again, it's very similar to brainstorming. I would ask AI, okay, for example, how would a cowboy say, how are you? And the AI may give me some ideas. And again, as a writer, I definitely would not take it as it is, but it gives me some ideas how we can do things. But I would, as a moment, I would not go as far as, okay, just let the AI handle the conversation, the dialogue completely. Also, as I will show you later on, currently there are certain AI tools allows you to work in spreadsheet, like a tabular format already. So the following examples are from Maker Suite. It's very similar to ChatGPT API, but with a web-based interface. So it's if you want to build like a very quick prototype or just want to experiment some things, it's a very good place to start with. For example, in this screen, you can define a prompt. This prompt is rewrite the following line in a parrot lingo. So what this would do is basically you can think this prompt as a function. So you can give this function different input, and it will always produce the output based on your prompt. For example, if I apply this prompt to different inputs, if the input is hi, how are you? Because the prompt is rewrite this sentence in pirate lingo, it will say, ahoy there, matey, how be I don't know even how to impersonate this. And if you give it a different input, do you enjoy the gathering? And the pirate will, and to say in a pirate way, it will say, do you enjoy the shindig? I hadn't even heard of this word. But again, I probably still would Google what shindig means exactly and what context I can use this word, but it gives me an idea. So this is the idea of this. So the API maker suite course is called PALM, PAAM API. It's developed by Google. So the idea of this API is basically you can apply this prompt, this transformation to an input, and it produce an output based on the rules you define. You can imagine it as chat GPT, but you can apply it programmatically. And another example is you can already work in tabular format. For example, this is something like, again, I will not use this in actually release game, but I'm sure a lot of you had this experience of a lot of language. When you translate them, you need to consider who the speaker is. Is it a male? Is it a female? And sometimes even what the personality is. So you can define a rule like this. For example, you have the original sentence in English, because English language there is no gender in English language. And in the second column, you define, is it a man or a woman said this? And then you translate into languages that do have genders, for example, French and Spanish. And this is a rule you define, and then you can apply this rule in tabular format, to data in tabular format. But the translation is probably not perfect, also because I cannot check if this is a genuine good translation of French or Spanish or not, but you get the idea. And yes, currently large language model APIs can already produce chats. For example, here the example is you can ask the AI to pretend you are a snowman and have a conversation with the user. You can give it a context, a personality for the AI to perform. But again, I will not use things like this myself, also because I'm aware that there are a lot of controversies like about the data different companies use to train their model. But I cannot rule out, in the future, this technology can be perfectly viable. So takeaways. So I think the important takeaway of this talk is when you walk out the room, if there are, like I said, you absolutely shouldn't consider use all the services I mentioned or recommended. But if there are one or two things that inspires you, I think I can consider it a success. And one motto. Whenever you want to do something, ask yourself, can I automate this? The chance is you probably don't need servers. There is a service can do it just fine, and with less maintenance, more reliable, and cost effectively as well. And with that, thank you for being here. That's me.
Thanks a lot. Even though the topic, particularly for me, it was quite tough, but I hope someone in audience has some interesting questions.
Thank you for your presentation. It's such quite amount information here. So I have a question about maybe you have provide some tips for tracking value of services. You know, today we have too many different complex type of services, AWS, maybe Azure. They have some rules and costs of different components which you can integrate in your product. So maybe you have some tips how to manage this type of complexity, how to navigate through your cost and make some optimal decision about your game value.
It's so I think your question is like, are there any tips about how to best utilize?
Yeah,
public
maybe how
cloud
to
service?
automate this process because in your talk is very beautiful idea about that you can make some automation process through all the development stage. You make some adjustment for your product that ready for this type of architecture. And this product costs you money. So maybe we can automate this process to track how many we spend on our new changes in products and automatically.
Yeah, so it's like obviously best practices and cost management is a very, very big topic, and they are actually in AWS. They are specialists employed by AWS. They specialize in cost management. So if you ask me like personal, maybe top 3 tips, I would say first is if you are a small team, cost management it probably won't be immediately so important to you because, as I mentioned, those most services are paid by usage. If you use little, you pay little. But if your cost really ramps up because maybe you have many players playing the game at the same time, I think the best place to start with is since you are by definition a bigger customer already. I know like in AWS and Google Cloud, they have those specific like teams that supports actually gaming technology tech like games companies, and their customer can range from like medium-sized game developers to very big multinational game dev companies. But definitely good if your cost really ramps up, definitely do get in touch with them if by any miracle they haven't found you already. And they can, because I know some of them personally, I know they really quite keen on solving the problems and especially taking on challenging and new problems. They really do this. They think it's they really do this for fun, and yeah, definitely get in touch with them. Secondly, is there are many best practices like articles, like Google Cloud or AWS they would publish, and those articles they are most of the time they're really well written, and if they give you like 10 best practices of best cost saving, definitely make sure you have read them through or have your engineers read them through, and they are there for a reason. And the third is, I think one way to save you money at the start is probably like today I mentioned switching from servers to services if you can, because servers, no matter how small it is, even you have just a medium-sized server running there 24/7, it would cost you money. It would cost you at least the $100, $200 per month to start with. Whereas if you switch to services, you only pay for usage. Like by usage, give you an idea of how, like for example, cloud functions can be priced. Off the top of my head, I don't know the exact pricing, but it will be something like, okay, for every 1 million requests, you pay a certain amount of money. So as you can see, like if you don't have a 1 million request, you probably pay very little. And when you actually have 1 million requests per day, you probably make a lot of money from selling of the game already. So actually being cloud native is probably the easiest way to get you started on cost saving.
Okay, thanks.
Some other questions? Yeah, here.
Yeah, hello. Thank you for your presentation. As I understood, your game is based on some data from the cloud services like Firebase and so on, right? So this game is based on some data from the Firebase, right?
No, this game is a murder mystery game, and which allows you to play with friends. I should mention, like all the stories and cases here are
Okay.
handcrafted and written by human, and so it's not very different from any point-and-click mystery games. And the only difference is just the technology, the multiplayer technology it uses.
So my question is more about, okay, I understand the ability that, for example, if my data, I mean gameplay data about some costs, some values, about the, I don't know, damage, etc., is based on the cloud service. So, for example, if somebody is install my game, he don't need to reinstall it or do something else. I just tweak some gameplay mechanics inside it. Inside, for example, Firebase, and it will be automatically download from for this demo game. But what you say about if this game will be released and I will totally be like in the hands of Firebase, how it works? Does it a good idea to what is the good idea to diversify these risks about using the cloud services? For example, something can go wrong with your cloud item or something like this.
Yeah.
What is the good solution for it? Download it and use it on the server side or on the user side, or what is best practice? Thank you.
First, I think I want to say is like there are always things that can go wrong, and when whatever game, like even it's a single player game you released, I think on Steam always there are 5% of players they would complain, oh, this game for some reason doesn't run on my computer. So there are a lot of reasons things can go wrong. I guess what you're asking is how reliable a service like this is.
Basically, yeah. Does it good idea to? I understand when I develop the game, I constantly need to change some values and etc. But when I release the game, does it make sense to just rely on the cloud services like Firebase?
I think the short answer is no. If you don't need to use cloud services, like some of the cloud services you use at development time, so it helps you with development. Some of them you use with your released game. And again, if you don't need network capability in your released game, it's just a plain single player offline game, you absolutely don't have to use cloud services. And I think I agree with you, the best is to not use it, because you cannot expect players, even like in most connected regions, to have always on internet connectivity. That is unrealistic. So if if there are reasons you shouldn't use it, yeah, don't use it with release the game. Yeah.
Okay, and one more question is, for example, I forgot about it. Sorry.
Okay, so I think we've already got the time. So thanks a lot for the presentation. It was